Hello everyone, this is chapter 5 for class 6th physics, that is work, energy and machines. In this chapter we will discuss in detail about work and energy firstly, then how the machines are doing the work with how much energy and all things we will discuss later in this chapter. So firstly, the work and energy. These are very two common words which we are using in our everyday life also. We are doing different kinds of work, activities like homework, classwork, different things we are doing, and it is only possible if we have energy in our body. So sometimes we can say also, we are saying like, I don't have enough energy to do this work right now. So that is, work is possible only if the person is having energy. Both things are interrelated in the form of normal life also, in the case of science also. But for measuring work, there is no any specific measuring equipment or tool. It is only possible to measure that how much work is done by how much result is produced by it. Let us understand these two different terms with the help of some examples to understand it more clearly. First is the work. Now what is work? As I said, we are doing the many different kinds of work at different places. So these are here. Now there is no any specific thing to measure the work without how much result it is producing. Now what is the meaning of this? Like if any person is applying some force, pushing a box, it is doing the work. Means the person is applying the force with the help of the energy, and the box is changing the position from point A to point B. The work is done here. Energy is used in the form of the force, right? Now, how we can measure how much work is done here? This is the point of displacement, how much the distance it covered after applying that energy or force. So this distance covered is the result produced. This much work is done. Further, in detail, we will discuss how we can measure the work mathematically. Okay? Now let us take one firstly define, then we will discuss the example. Now what is the work? Work is done when the point of application of a force moves through some distance. What is the meaning of this define? Work is done. Here also work is done. When work is done? When the point of application of a force. This is the point, this A point is the point where I am applying the force. So this is the point of the application of force, where the force is applied to move this body through certain distance. Now in general, we can say that work is done when the force is applied on a body to move it through certain distance or some distance. Okay? Now let us consider one example here. What is our first example? This is the horse which is drawing a cart. Now when at point A, this is the point A, at point A, the horse is applying the force F1, and this cart started moving. As the horse started moving forward, the horse stopped at point B, and this is the distance covered. So when the horse with the cart moved from point A to point B, we can say that the horse has done some work. This is the example of the work done here. Next, one more example is here, that we can see the picture at the next page. Firstly, let's see what is the example about. One child is there. The child is applying the force F2, we can say, on the handle of the bucket, and the bucket will move obviously upward as the handle will move up. So means that the child does some work to apply the force, or rather than the force applied by the child on the handle does some work. Means we can say that the child is doing some work to carry up the handle of the bucket, or we can say the handle is doing some work to carry up the bucket surface. You can see the example. This is the figure of that one, that a child is carrying the bucket from the handle, or we can say the handle is carrying the bucket. The bucket, this is the surface, ground surface we are assuming, and this is the surface to which we are taking the bucket up. So this is at height h now. Done. Now, how to measure the work done here for these two cases, for the second example and for the first example of the horse? What is the main thing to do? This is the second defined for the work done now. What is it? The work done by a force is equals to the work done by the force is equals to what? It is equals to the product of, means multiplication of the force and the displacement of its point of application in the direction of the force. This line is just to make you understand at which point, from which point we are taking the distance, which force we are taking. Okay, the general thing is that the work done is equal to the product of the force and the distance. The displacement we are taking that from the point of application to the direction in which the force is applied, or up to which the object is moved actually, or the moving. Okay, for the first example that we took for the horse and the cart, that is the force is F1 we would took here there, and the displacement is D. So what is the work done in that case? That is, work done is equals to force multiplied by distance or displacement. In the second case, force F2 we took, displacement is H here. So work done is F2 multiplied by H. This is the value for the work done. After finding the values, numerical values for these two, we are able to find the numerical value along with the unit for work done. Now unit, what is the unit of work done? The unit of work is, as it is equals to the force multiplied distance, so the units of force and distance multiplied together will give us the units for work. What are the units of force? It is Newton. Distance, it is meter. So the units of work is, that is Newton meter also we can write, or joule, having symbol J. Done. This is the joule here. Next topic, the second topic of the chapter, that is the energy now. What is energy? Energy is basically the ability to do work. That is energy. Or in other words, we can say the person needs energy to become able to do some work. Right? Now, energy can exist in many forms. What is energy? It is clear? Okay. Energy can exist in the many forms. In many forms how? Like food we are eating, it is giving energy. The fuel we are putting in the vehicles, it is giving energy to them to move on. Right? So these are the forms of the chemical energy. And the sun is giving us heat energy and the light energy also, solar energy as well, which is used to make electricity. Right? Electrical energy is also the kind of energy which is used to run trains, machines and light up homes, so on. Many things are there which are working on the electricity. In detail about the different forms of energy you will discuss in the higher class. Now come to the units of energy. As I said earlier, the energy and work both are very much interrelated in general life also, in the case of physics and science also. So the units of energy are also similar and same to the work. Since the energy something has is defined the amount of work it can do, so energy is also measured in the same units as of the work, that is joule. Right? Now come to the third major topic of the chapter, that is the machines, which is the very main and important topic of the chapter. What are machines now? A machine is a device through which a force applied at one point overcomes resistance at some other point. But these things you have already done in the last 5th standard in science. Under the machines, we will discuss the 6 major types or categories of machines. What were that 6 main different machines? First is lever, wedge, screw, inclined plane, and 2 more were there. These are the kinds of the machines. Wheel and axle, that is, and the another one is the pulley. These are the different kinds of machines. Now why they are called machines, or what is the meaning of the machine actually in general life? The machine is that device by which we are applying the force at certain point, and it helps us to do the work done on the other point, to overcome the resistance, to overcome the difficulty to do the work at some other point. Okay, what is the different kinds of machines that we will discuss further? Firstly, we are taking one example to understand the concept of machine properly. The example is like we are having a container filled with sugar in it. We are taking a scoop just like the spoon. When you scoop up some sugar with the spoon, you apply a force on the spoon, right? Now the force at the one end and the other end lift the sugar, right? Like we are having spoon, and when we are applying force here, the sugar is picked up at the other end. So we are applying force at the first end and the work done is there at the other end. The resistance is overcome at the other end. This is the meaning of the machine. So to do this, the spoon has to overcome the force of gravity that was acting on the sugar. So this is the resistance offered by the sugar actually. Thus, a spoon is a machine. The spoon is acting as a machine which made a work easier. Similarly, a knife is also acting as a machine. You apply the force on the handle, and while the blade overcomes the resistance offered by the vegetable, and you are cutting it easily. The two different machines are clear with the help of the example. The next one is now a little thought will tell you that the most of the common tools we are using in fact are the also machines. In our everyday life we are using so many different little big tools which are even also the kind of machine. Now what is machine actually? The machine is that which make our work easier and we are able to do the work with a lesser energy or force. So the device that usually refer to machine on the other hand have the large number of sections or pieces. It means a device which is actually acting as a machine is even itself containing a large number of machines in it. Just like the example, the sewing machine or the bicycle. These are having many sections that are themselves the simple machines. For example, in bicycle, wheel and axle is used. Bicycle itself is a machine. Ball bearings are used. So many different things are there which make work easier and act as a machine. Now what are the functions of the machines? We will mainly discuss the four main functions in this chapter. The machines are able to perform the number of functions of the device. The first is changing the point of application of the force. We will discuss all these 4 points in detail with the help of the examples. What is the meaning of the first one? Firstly, changing the point of application of the force. You can see here in this picture, we are having a forceps here. We are applying the force in the middle, but it is acting at some other point. We are picking up this gulab jamun from the other point. This is the point which is joined together. So this is acting as the fulcrum here, right? Or we can say we can use the tongs also to take it. It means when something is too difficult, too hot or cold, too difficult to hold it. Or in other words, we cannot apply the force directly on it. So usually we are using the tongs in that situation. We can use the tongs, tweezers, forceps, anything. Do you want to contaminate, not to contaminate the thing, and to work on something fine or delicate, we are using these kind of things, right? So we apply force at the one end of the tongs while the other end applies the force on the object. Like we are applying the force here and the other end of this is applying the force on the object, this one. Thus the point of application of the force shift from the one end of tongs to the other end. Means this is the machine. Because the force is shifting from one end to the other end. Okay. Now the spanners are used to tighten or loosen the nuts. What are the spanners now? The spanners are which are having of this kind of shape that are used to open or close the nuts, bolts, to lose them, to tighten them. And we can use a screwdriver to work on the screws which make our work easier. So it means these are the machines, these are the simple machines which make our work easier. We are applying the force on any other part, and it is giving the outcome by applying the force, by giving the outcome of the force on any other part. And these kind of machines are also used in that cases where we can't reach by ourselves. So one of the main advantages that of the simple machines, that they help us apply the force on the things located at points that are difficult to reach by our finger. We can't just tighten the screw obviously, and the nuts and bolts are also sometimes very difficult to take it open or lose it with the help of simple hand only. That's why these are the simple machines which are making our work easier and make the reach possible at the places which are not easily we are not easily able to do the work at the places and that places. Okay, second one is, now the second is changing the direction in which a force has to be applied. What is the meaning of this? Now let us see one of the main example. Before looking at the example, one very important key point is here that we must need to know. We are saying that machines are used for changing the direction in which the force is applied. Just take the example of the valve here. What is the we are doing there? There is a pulley in the valve having the rope on it. There's the bucket tied with it, and we are taking a hand here. We are pulling the rope towards side downwards, and the bucket is moving up. Then this is the case there. What is happening there, right? So it means it is easier to use a body weight to push something down than to pull the same thing up. So we are pushing it down, this rope down. Instead of pulling it up, it is very difficult to pull it up, right? It means some machines make work easier by allowing us to apply the force in the direction that is convenient for us. The same is happening here also in this case. As you can see here in the picture, in the figure number 5.4, in this figure you can see that in the hand pump also, in the case of the well also, where the rope is tied or just placed over the pulley, which is movable pulley, which is rotating, and at one side the bucket is there, at the other side we are pushing it to our side, to downside, to make our work easier. What is the thing happening here now? This is the fixed point or the pivot point, and here this is the fixed point as the pivot point. Here is a case where we are applying the effort, we are applying the force, and this is the load which is going up. We are moving it down. See this handle, we are moving down with our hands, and the opposite part where the force is acting, to which part the force is transformed, it is going up as we are moving our hands down. So these are both opposite to each other. But if, just assume, if the handle is not there, we need to take this piston out with our hands. It is too difficult then. So this handle, and by pushing it downward, is making our work easier. It means here also a simple machine is acting. This handle is acting as a simple machine. Same concept is here in the case of well also. We are having this bucket. It is very difficult to take it out and pull it up like this way. It is too heavy, we will feel then. So we are applying a body weight to downside, and we are pushing this rope, and the bucket will automatically move to upside along this pulley, which make our work much easier. Hope this is clear. Then the third part, the third effect is changing the magnitude of the force required. Changing the magnitude of the force required means, as I said earlier also many times, what is the machine? Machine is making our work easier. We need to apply very less force, and it multiplied it. It multiplies it. So changing the magnitude of the required force means we are even giving the lesser force, but still the work is done with the same efficiency, as some things are there like this. Just take the example of this. Here is a bottle opener. If we open the bottle like with a hand, it will take much greater force. It needs actually. But if we use a bottle opener, it is too easy to remove the bottle of this lid of the bottle with very few energy, with very small energy. Same is here in the case of this scraper also. These are the spanners actually. The spanners are used to loosen tight the nuts and bolts. Right? As I said earlier, it is very difficult to just tight it properly with the hand and to open the tightened this nut. So this is the machine which is helping us to do so. So it is almost impossible to open the metal cap of the bottle with the bare hands, with the normal naked hands. And it requires a large force, as I said. So with the bottle opener, you remove the cap by applying very much smaller force on it. And the nutcracker, spanner, these are also used to carry out the different things in the same way. So we are just giving the smaller force, and it is just giving it by multiplying, by magnifying the force that we are applying. The last effect of the machine is changing the speed. Changing the speed means, like, wheel is attached with the paddle of the bicycle, and as we are paddling the bicycle, the wheel is working, right? It makes the cogwheel attached to the rear wheel turns much faster. How the bicycle is moving? We are paddling the bicycle. This paddle of the bicycle is attached with this wheel. This small wheel is known as the cogwheel. As the paddles are attached with the cogwheel, and the second wheel of the bicycle is also attached with the cogwheel with this chain. So as the paddle is moving, cogwheel is moving, and the chain is moving, the second wheel of the bicycle is moving. So here also this separately is acting as a simple machine. A bicycle as a whole is also a simple machine. What is the thing here? It changes the speed. As we are paddling fast, the bicycle will move much faster. As we are paddling slower, stop down paddling, the bicycle slow down, ultimately stops also. So this is the way how we are applying the force, and force can change the speed as well. Now what are the different types of machines? There are the 6 different types of machines that we will discuss here. First is lever, very important. Second is the inclined plane, wedge, screw, wheel and axle, pulley. These all machines, the introduction you have already done in the last standard, but still we will do in detail here also in this chapter. First is levers. What is a lever now? What is lever in general? It is a rigid body that is capable of rotating about a point on itself. About a point on itself. What is that point known? That point is known as the fulcrum. We all know in levers there are the 3 different things. One is the fulcrum, load and effort. These are the 3 different things which are located on the levers, right? So these are the 3 different things. What is the define? Let's read it again. The lever is a rigid body capable of rotating about a point, about this point, fixed on itself. Lever itself is containing this fulcrum point. A rigid body is a body which does not change its shape when force acts on it. That is a rigid body. That is a solid hard body. Thus, the metal rod or the stout wooden stick is a rigid body. Stout wooden stick is the old person which they are using for walking purpose. That hard stick is known as the stout wooden stick, and the metal rod, these are acting as the rigid bodies. Obviously, they are solid rigid bodies. So when such a body acts as a lever, it rotates or tends to rotate about the some point on itself, and that point is known as the fulcrum. What is fulcrum? It is clear. It is the fixed point on any rigid solid body about which this machine is working, moving, rotating, whatsoever. And the fulcrum of a lever is the point about which it can rotate. Same thing is written again. Okay. Now, the stick resting on the man's shoulder here, which you can see, is also acting as the lever. How? You can see this is the fulcrum, fixed point on the shoulder. This stick on the shoulder is acting as the fixed point. This is the load. Here the person is applying the effort to take this properly on the shoulder. It rests on the shoulder and can rotate about the point, that is the fulcrum, usually denoted by the letter F. What is the effort? That also I explained to you. What is effort? Effort is a force which we are applying. The force applied to the lever is called the effort. The point at which the effort is applied is known as the effort point. So, this point is the effort point. Effort we are applying here, it is denoted by letter E. And the distance FE from fulcrum to E. This distance is known as the, what is it known as? It is known as the effort arm distance. Effort arm it is generally. Okay. Next is now, what is load? What is load? It is the resistance overcome by lever is known as the load. The thing which we want to move from the place. That particular heavier thing which we are applying the effort we are applying for that load only to balance it. That's why. So the resistance overcome by lever is the load. In figure this also you can see resistance overcome means like this effort we are applying to balance it. We are having the load here. The weight of the bundle acts downward on the stick. So this resistance overcomes by the stick or the load. Load is this is the load point now. This FL from fulcrum only we are just taking the distance. From fulcrum to load, this is known as the load arm because load it is. For the other one it was the effort arm. This is the load arm. Okay, next is now the levers are, this is very important line. The levers are grouped into the three classes or types on the basis of the relative positions only. Into the three classes the lever is classified. Into how many classes? Into three classes or three categories the lever is grouped or classified, and it is just because of the relative positions of the fulcrum, effort and load. Fulcrum, effort and load, because of the difference in the positions, it is classified into the three categories. Let's discuss that in detail now. Now listen carefully. I'm gonna tell you a very amazing thing to remember all the classes of lever properly tip top. This is a very amazing tip. How to learn it now? Okay, this is the first class lever, the A figure. This is the second class lever. This is the third class lever. Right? These are the three different classes of lever. In lever, we all know there are the three different things: fulcrum, load and effort. These are the three things. Now listen what is the trick here. In the load, in this letter, only one horizontal line is there. So I'm giving it 1 number. In this 2 horizontal lines are there. So I'm giving it 2 number. In this 3 horizontal lines are there. So I'm giving it 3 number. Okay. In the first class lever, what is the arrangement of the fulcrum, load and effort? It is 1, 2, 3. This is for the class 1 lever. Done? How to remember it? Second now. For class 2 lever, this load and fulcrum will interchange each other. It will come to that place in the center. It will take this place, means the place of the fulcrum. Okay? So the load comes in the center and the fulcrum goes there. Load comes in the center and the fulcrum goes there. What is the order now? It's 2, 1, 3. Okay? Just the second and 1 is interchanged for 1, 2, 2. Means when we are jumping from first class lever to the second class lever, we need to interchange the 1 and 2. We need to interchange these two. It is clear the arrangement of the second class lever also? Hope it is. Then for class 3 lever. For class 3 lever, firstly 3 wants to be in the center. Okay? 3 wants to be in the center. So 3 will come in center of these two. Clear it is, bache? 3 wants to be in the center at the central position. So 3 will come in between these two. Fulcrum is on the same place, 2 number. Effort came in the center. load will move to the last one place. This is the arrangement of the third class lever of effort, load and fulcrum of all these three. In all the three different classes of lever are clear. What is the arrangement? It is clear because the arrangement is the main. After this, you can take any example, any of the example from this picture, from any of the figure. You can take any example and just match it where the fulcrum is existing, where the effort we are applying, where the load is there. You can easily classify this is related to which class lever. That's it. Okay. Class 1 levers now. Class 1 levers are that where the fulcrum is lying in between load and effort. So this is the define of class 1 lever. In class 1 lever, fulcrum lies between load and effort. Okay? Means the positions of load and effort with respect to fulcrum do not matter. What is the meaning of this? Fulcrum is here, that we need. Fulcrum may be to little bit this side also, little bit more to this side also. It doesn't matter. But the fulcrum must be in the center. That is the main point. Okay? So here now. These are the different examples. First is the tongs are here, scissors are here, pliers are here, which are acting as the class 1 lever. Okay, you can see this part you can read by yourself also. It is very easy, or we are doing it faster here. Just see it. What is it? You will see that once you stick acts as the class 1 lever, as the fulcrum is in the middle and the load. Okay, what is this? This example we have already done. The last example we just done with the man, with this one example. This is that, in which what is there? The stick was acting as the class 1 lever. In that last example, we know how the fulcrum was acting. Fulcrum was that part which where the stick was lying on the shoulder of the person. Here the load was there. Here the effort the person was applying by the hand. This was the system completely. Okay. The next is another common example is the type of the lever is the seesaw. Pivot is the center, that is the fulcrum. And while the two persons are sitting on the either side, which are acting as the load and the effort. But this part is clear. What is the seesaw? All know? Okay. Fulcrum is the central part, which is a fixed point. Two persons are sitting on the either side. One is acting as the load and the other is acting as the effort there. Okay. Hand pump example, that is clear. Okay. Next is, this is also clear. I have explained these all already. What is the thing here? The pivot about which it moves is the fulcrum. The hand pump they are talking about, and the force applied is the effort there. And the piston exerts the force on the other end, which is acting as the load there. Scissors are there, pliers are there, so many other things are there which are identical and which are acting as the double levers, since they have the two identical levers working together. Because the two identical same levers are there working together, that's why they are having the double levers. Double levers means like in scissors also 1, 2. Two identical levers are acting. In this tongs also 1, 2. In pliers also 1, 2. Two things are there, so double levers are acting and they are identical at the same time. Class 2 lever now. In class 2 lever, some examples are here. You can see the effort is we are applying at one end. Fulcrum is at one end. At one side fulcrum is there. Load is in the center in the second class lever. Load is here. We are applying effort at the last. Load is applied here. Okay. These things are also clear. So these are the examples of the second class lever. What is the define for the second class lever? Load is situated between the fulcrum and the effort, or in other words, traditional strota. What is a sarauta? This is this kind of device which is used to cut the things in the ancient traditional period. And to open up this, that is the bottle opener. It is also acting as the class 2 lever. Now, here is the complete explanation of it. We know in the class 2 lever what we were doing. we are just applying the force, effort at one end. Fulcrum is the, just we are taking the example of this bottle. In the bottle opener case, this is at the, we are fixing at the top of the bottle, we are applying the force here, effort here. This part we need to remove. Here it is acting as the load on which the resistance we want to overcome, we want to take it out. Okay, so what does it mean? This, that part that I said which was fixed on the bottle was acting as the fulcrum. The resistance offered by the battle nut is the load, and the force applied on the handles is the effort actually. Same with the bottle opener, same thing is happening. Some other examples of the class 2 levers are the nut crackers, wheelbarrows, paper cutters, photographic shops and closer hammers. These are so many things are there, so many machines are there which are acting as the class 2 lever. Come to the class 3 lever now. In the class 3 lever, we know the force, this fulcrum is acting at the one end. The effort we are applying in the middle here. See, the effort we are applying in the middle, and the load is at the other end, at the opposite end from the fulcrum. This is the arrangement. So, define is effort lies between the load and the fulcrum. Which lies? Effort lies in between the load and the fulcrum. Okay. In the case of stapler now, in the case of staplers, what is there? There's the two sections are provided at the one point. The two sections which are pivoted at one point, this is known as the fulcrum. Where the fingers we are pressing the two sides, this is acting as the effort we are applying. And we want to take the two things collectively, we are stapling it. This is the load where it is acting. Same with this tweezer also. Fulcrum is here, we are applying the effort in the center. This is the load. Load is what? The thing that we are picking up with the help of this tweezer. Okay. In the third case, we have with the arm, this elbow is acting as the fulcrum. We are applying the pressure on our arm. This is the effort we are applying. The load is that which we are keeping on our hand for the longer time by holding our hand or arm upwards. Okay. Now come to the second machine, but this was the first machine that we have done, that is about the levers. 3 different types of levers are there. How to remind it, hope so this is also very clear to everyone. Next is now the second machine, that is the inclined planes. What are the inclined planes? Just see the common example, like this slanting side is known as the inclined plane. We can see the inclined planes at the many places, like in the hospitals, in the societies, even in the large offices also, post offices also. What is it known as? It is known as the ramps also. And these are used for the movement of the wheelchairs and the loads, for loading, unloading the different things into the society and taking things out easily. Why? Because the sliding or rolling of the objects is very much easier as compared to the lifting the object over the stairs. So that's why these kind of places are having the stairs also on the both sides, but in the large stations at the large overbridges, these slopes are also there instead of the stairs. Even along with the stairs, these kind of slopes are also there, which help easier the movement of the wheelchairs and the loads and the labors against the loading and unloading of the trucks for the fruit grain markets, like for the wheat, for the large amount of rice, for loading and unloading of the trucks. Even they are also using the temporary inclined planes. What is a temporary inclined plane? They're just using the wooden plank, thick plank there, and making a temporary this kind of inclined plane to keep the things easily on the in the truck, to load the things easily or unload the things easily. That's why the inclined plane is used, and how it is used is clear. Now, the inclined plane as such, it is not showing any kind of same define satisfaction of the machine, because what is the define actually? It is the overcomes the resistance at the other point. There is no such thing, but the inclined plane is actually the doing work of the great convenience for us. It is not really actually a machine, but it is doing the work on the principle of the screw. That's why it is considered as the machine. The wedge, Next machine, the third machine is wedge now. What is wedge? When we join the two inclined planes, this is an inclined plane, this is an inclined plane, but when we are making the inclined plane, it is here, from here it is thin, then it become thick, right? When I join the two inclined planes, like opposite, this is the sharp edge now, this is the thicker part. Same, this is now wedge. What is wedge? It is clear. Now it may be of the small wooden piece or of the metal also. It is very thick at one end and thin at the other edge. That is the wedge. And it is used by the woodcutters, carpenters to cut or join things or do the different works. Now they are also jammed into the logs also. Jammed into the log means it is put like this so that the end do not press on or will not become damaged. That's why. And this kind of wedge is also used in the door stoppers. For door stoppers, how it is used? When this thin end is placed in between the door and the lower edge of the door, or we can even place in between the floor and the door also, then what will happen? It prevents the door from the moving. It will keep the door opened or closed, whatsoever you want to keep it for the longer time. Then the next thing is, you can see that the wedge is basically the two inclined planes that I already told you. The force applied at the blunt edge overcomes the resistance across the inclined plane. This is the blunt edge, the force that we are applying here, it gives to the other edge. Now, for wedge, the examples are the knives, chisels, axe and needles. These are all the examples of the wedge. Now come to the screw. The screw is what? We all know the nail, right? This is the kind of screw. What is it? We can make the screw simply by having a pencil and cut the sheet of paper in the triangular shape. By taking the triangular page, what we are doing, we are having a pencil and we are just rotating that triangular sheet along with the pencil. Here is the dark colored shaded line here that I took on the triangular page. When I rotate this page along the pencil, you can see these are the threads formed here. Similarly, on the screw also, these are some fine lines which are known as the threads or grooves on the screw. It helps the screw to fix it more properly in the wall. And one more thing, instead of using the nail, the screw is giving the more easier work for us, because we can use the screwdriver to fit the screw into any place, into the wood, into anything. And it is having the greater strength or grip to fix the things along with the other wall or the objects we can easily fix with the screw. The another advantage of the screw is over the nail is that we can just simply drive it in. It is too easy to drive as compared to the nail, right? Then the next thing is, when the screw of the jack, two things are there, bache. Screw is there, which is the alternative of the nail, but even from the nail the screw is better. The next thing is that the jack is also acting on the principle of the screw. What is jack? That is used to lifting up the cars, right? That is the jack. When the screw of the jack is rotated by the long handle, by gradually pushing up the car, and the vise used to grip the cars or the larger heavier objects firmly on the workshop, and it is having the common application of the screw. This is very common application of the screw, and it is used in the jacks also, which is used to lift up the heavy materials or the cars for changing the tires up in the workshops also, or normally also it is used at the various places when it is required. And the next thing, the object is held between the jaw and the vise. The one jaw is the fixed, like this kind of jack is there, the one jaw is fixed and the second one is movable, that is rotating, that is turning its handle, and how much space we needed to fix the thing object in between it, we can just fix it alongwise how much we are required. Simple screw is clear. These are the threads or grooves on the screw. It is clear. It is better than the nail. how we can form. This is experimental review. Why it is very good machine? Because it gives us the great fit. It just fit properly into the wall and gives the strength to the object in which we are using. The next is the wheel and axle. What is the wheel and axle? Wheel and axle is also used in the bicycle. Even the screwdriver also is having the wheel and axle arrangement. So see in this picture, the wheel and axle arrangement can be used to magnify the force. This magnifies the force and to magnify the movement also. But say, as I explained this same thing you here in the case of bicycle also, I already explained the wheel and axle here. What I said you, this is the speed magnifier. Speed magnifier, how? We are rotating the paddle, very small piece. This complete wheel started moving very much faster. So this is the example of the wheel and axle. This is the axle, this complete is the wheel. Here also this is the wheel, this is the axle here. So it means in bicycle you can see this wheel and axle in arrangement in the many places. Then the next thing is screwdriver also, it is having the wheel and axle arrangement. This is the axle, this thin part, and this handle is the wheel here. Now many of our everyday actions involve the turning something, right? This could be a tap, doorknob, screwdriver, or the steering wheel of the car. In each case, the actual object which needs to be turned is usually the thin rod, such as the spindle of tap or shaft of the screwdriver. But if this is clear to everyone, it is very simple. These are actually the examples where you can find the wheel and axle arrangement. They are saying that everything which needs to be turned around, they need the thin rod to be moved. That is the spindle of the tap or the shaft of the screwdriver. This is the shaft of the screwdriver, or the top of the spindle, we can say, that is moving. Actually, when it is moving, this smaller axle is also moving. So we need the movement of the axle here to do the things properly. This axle we needs to move actually. Okay, then the next thing is, since it is not easy to rotate a thin rod, the common practice is to fix with the wider handle or the knob or wheel. So since it is not easy to rotate the thin rod, we are doing the common practice. We are just widening the handle, we are providing the knob or the wheel to the rod, which are turned with a small effort. So this is the wheel which is turned over with a small effort. This is the wheel which is turned over with a small effort, and the axle will start moving. Okay, such an arrangement is known as the wheel and axle arrangement, and the thin rod which needs to be turned is known as the axle, and the wider object fixed at the axle which we are applying the effort, is known as the wheel. In many cases, the wheel is not actually circular in shape. For example, the handle of the bicycle. The little thought will convince you that the spinner used to tighten or loosen the nuts and bolts acts like the wheel, though it looks like a lever. Okay, but it actually looks like the lever because it is having the some fixed, like we are applying the effort and we are having the load in it. In the examples, we have discussed that the small effort, the force we are applying on the wheel, can produce the much larger force on the axle. Just as I gave you the example in the case of the bicycle, we are applying the very small effort on the pedal and we are getting the much larger effect on the wheels. The wheels start moving very much faster. But here we are applying the effort on the wheel. This is acting as the wheel, this circular part. On the wheel, when we are applying the effort, this axle will start moving with much larger force. The wheel and axle arrangement can also be used to magnify the movement. Magnify the movement means movement become very much faster and it just show the movement properly. Because the movement is faster, we can see the movement. For example, the effort that turns the axle produces a much larger movement of the wheel. But these two things are clear. In the cars also, the two tires are attached with this kind of lid, that a rod. So this is acting as the axle, this is the wheel. Okay, the last simple machine now, the last machine is the pulley. What is the pulley? Two different types of pulleys are there. A pulley is also the wheel or the disc which can rotate freely about its axis. The string or rope passing over the pulley, it is making it working. See here, the string or the rope passing over the pulley fits into the slight depression along its rim. Means, what is the shape actually? The pulleys of this kind, two different wheels are there. From the center there is some space on which the rope is actually fixing properly on it, so that the rope can fix, the string can fix properly on it. That's why that slight depression is there along the rim of the pulley. So the one end of the string is attached to the load. One end is, just assume it is attached to the load. Like here is a bucket. So it is attached to the load and the effort is applied on the other end. From here with the hand we are picking this rope away from the well. So this is the point where we are applying the effort. Okay, so the advantage is that the point at which the effort is applied and the direction in which the applied can be made convenient. That's why only we are using it. This point also we have earlier already discussed in proper detail in the case of the well bache. Okay, so remember that the pulley merely changes the direction in which the force has to be applied. It does not magnify the force, it is just changing the direction. It doesn't magnify the force. How much force we are applying, it will give the same output. How much we are pushing it with our hands, only that much the bucket will come up. So it is not magnifying the force, it is just changing the direction of the force. Only this thing it is giving. Okay, the next is the most common example of the use of the pulleys on the top of the well. Same thing is given here. You took the inside and the engine of the motor car. You will see that three pulleys connected by the rubber belt. Yes, with the rubber belt inside the car motor, the engine, it is connected with the different pulleys. The toothed wheels of the bicycle, chain passing over them, that is also connected with the pulley. Yes, strings used to draw the curtains or blind passes over pulleys. Cranes also used the pulleys to lift the heavy things, heavy objects. Now the last main part, that is also very important one, that is the mechanical advantage. What is the mechanical advantage now? The mechanical advantage of the machine is the ratio of the load and the effort. This is the main formula bache, which you have to keep in the mind. This is mostly used in the numericals and it is very important question also. This can come in the numericals also. Now in several examples of the machines that we have discussed earlier, the small force or effort moves a greater resistance or the load. So however, what we gain in terms of the force we apply, we lose in terms of the distance through which the applied force has to move. What is the meaning of this paragraph actually? There are different things. We are applying the force, effort, which overcome the resistance, which move the load. So what we are gaining actually in terms of the force that we are applying, it actually gives the distance. How much distance it is covered through, lost in the terms of the distance. How much force we are giving, it is lost in the term of the distance, which is applied force or effort which is moving actually. So the amount of the work done remains the same. Amount of work done remains same obviously, because here is the box. Listen, we are applying the force. The box is moving through the distance. How much force is given, it is lost in the distance covered. So both things are equal, both things are managed, because the amount of the work done remains the same. How much force is applied, that much distance is there. So losses and gain, both things are equal here. Thus the machine does not really do any kind of work for us. It just makes the things easier by allowing us to exert the lesser force. Machine is nothing, it is just giving our work easier by applying the very less force. That is the simple define of the machine. Now, what is the mechanical advantage? The amplification of the force which the machine help to achieve is the mechanical advantage. But in general, the mechanical advantage is that which is giving us the idea how much load we can move by how much force, by how much effort. Okay, so this is the point you need to remind as the define the mechanical advantage of the machine is the ratio of load to the effort, not effort to load. It is load divided by the effort. See, this is the formula. Okay, now there is one more equation here, which is the generalized equation, very important one. The work done is same on the two sides of the arms, we know, because if there is the fulcrum in the center, here is the load, here is the effort applied. So on the both sides the equation will remain same. It means the load is multiplied by the distance moved by the load arm, effort multiplied by the distance covered by the effort arm. Load is equals to load arm, effort is equals to effort arm. Sorry for the inconvenience. What is the thing we were discussing? The load is multiplied by the load arm is equals to effort multiplied by effort arm. Same formula is written bache here also. This one formula is picked and written here. Now as the load and effort, these are two here, so we can take this thing, the load and effort, in the case in the form of the distance also. Means the mechanical advantage we can find even if the distance given, the distance of the effort arm, load arm, or even if the load and effort given, then also we can find the numerical portion. Okay, one point is left here now. The mechanical advantage, obviously this is the any particular value, just assume, is given to us. The load is of the 5 kg, the effort we are applying is the 5 Newton, force we are applying, like, right? So this will become a numerical value, but the mechanical advantage will maybe, or it will give the greater value, greater than 1, or it will give the less than 1 value, or it can give the equals to 1 value. Now, when the value of the MA, mechanical advantage, is greater than 1, it means it is acting as a force multiplier. We need to apply very less effort and it will work as a very good machine, will give the greater output result. If the mechanical advantage is less, it means it is the gain speed. It will just gain the speed. It is not a force multiplier. Then the last, if the mechanical advantage is equals to 1, it means the effort is equals to the load and the machine is used to just change the direction, just like in the case of the well. Now but 3 solved examples are here, very easy examples are here. After that you have book exercise that we will discuss in the next video. Only 3 solved examples are here, just take a look fast on these also. What is the first one? Calculate the mechanical advantage of the lever in which the effort arm is this and the load arm is this. See, firstly, the first main thing to do here is both the units are in the same unit. Both the values are in the same unit. So firstly, write what are the things given to you. Effort arm value is given, load arm value is given. What is the mechanical advantage? Effort arm divided by the load arm. This is it. Yes. One main point to be noted here is that बच्चे load is equals to effort arm write करना है आपने. See, load is here, load divide by, this is multiplied here, it will go into the division form. Effort arm we are keeping on the same place. Load arm is multiplied, it will go down, so load arm will go down. But when we are talking in the form of the effort arm and load arm, no, then opposite will come at the top. Otherwise load by effort is there. If you are talking in the form of the arm, effort arm, load arm, in this way it will come. So that's why the mechanical advantage is effort arm divided by the load arm. Do the cutting, you will get the answer. The next numerical is a 2 meter long crowbar is pivoted 20 centimeter from its tip. Calculate the mechanical advantage of the crowbar if the load is at the tip. Okay, crowbar is 2 meter long. Crowbar is what? It is also the kind of tool which is used to pick the stones. It is mostly used by the jewelers. It is used to pick up the stones. It is used to pick up the stones actually. Okay, so the length of the crowbar is 200 centimeter. Just assume the length, this is the 200 centimeter. Actually it was given in the meter, we need to change it into the centimeter, because for solving any of the numerical in any class of any chapter we need the same SI units. If it is in the SI unit, then SI, CGS, then CGS, like this. You already know this, we have already discussed these things in the third measurement chapter, right? So what are the things given to you? Just write down that. What is the formula for the mechanical advantage? Effort arm divided by the load arm. This is the fulcrum. Effort arm is, this is the effort, and this is the load. How this is the load? From where we are picking up anything, it is the load. This is the fulcrum. So its total distance is the 200 centimeter. So the load arm is 200 centimeter. Then okay, one more thing is given here. The crowbar is pivoted 20 centimeter from the tip. Means fulcrum is not here, fulcrum is here. It is 20 centimeter only from the tip. So 20 centimeter is the distance of the load arm. For the effort arm the distance is 180. Total इसकी length क्या थी? 200. 200 में से we will subtract the 20. We will get the 180 centimeter. That is the distance for the effort arm. Hope this is clear. Pivoted is what? Pivoted is the fulcrum. Fulcrum is 20 centimeter away from the tip. This is the tip. Fulcrum is 20 centimeter away. So this is the load. Fulcrum, it is 20 centimeter away. Total is the 200 centimeter. 200 में से 20 minus करेंगे, we will get the 180. 180 is what? It is the effort arm distance from the fulcrum. After dividing, you will get your answer. The next thing is, a cook uses tongs of length this. Tongs of length this means बच्चे from fulcrum to load. This distance it is given. Okay, here the effort will come. To lift a piece of the burning coal of weight this. Okay, the weight of the body is the force with which the effort pulls it. This. Okay, if he applies the effort at the distance of 10 centimeter, if it applies the effort at the distance of 10 centimeter, this is 25 in total. Find the effort. Effort we need to find out. Load, value of load is given, that is 2 Newton. Fill in the equation of this equation. This equation we have already done earlier, right? Write all the given things. Check the units. Fill this in this given equation. What is the formula for effort? Effort we need to find out. Effort is equals to, this effort arm will come in the division form. Put the values. The load is 2 Newton. Load arm is given. Load arm from L to this 25 centimeter. Effort arm means from effort to fulcrum, it is 10 centimeter. After doing the cutting and all, you will get 5 to the 10, 5 5 the 25, 2 will cut with 2, 5 Newton is the value for the effort. Hope this video is really helpful for you. Please like, share and subscribe to my channel. Share with your friends. Stay tuned. Work hard. God bless you all. Meet you in the next video.